This is the formula for total distance traveled by a bouncing ball before coming to rest. We will decode this equation in a very intuitive and easy to remember way. Imagine that a ball is dropped from a height, h, then the ball will reach h1, h2, h3 heights and so on, in its successive bounces till it comes to a complete rest. This is because after every bounce the ball loses some energy and hence there is a reduction in velocity. The ratio between the separation velocity and the approach velocity is called the coefficient of restitution. Before the first bounce the approach velocity is v, and the separation velocity v1 can be written as e times v, which is responsible for height h1, which can be written like this, hence h1 can be written as e squared times h. Now, while returning down the ball will cover the same distance of h1. During the second bounce, the velocity v1 is again reduced by a factor of e, giving v2 equal to e times v1, which in turn gives e squared times v. The height attained due to this velocity is given by this equation, which can be rewritten as e squared whole squared times h, and while coming back down the ball covers the same distance as before. Now, this process continues for every bounce of the ball until the ball comes to a complete rest. So, we can identify some repeating patterns like the separation velocity of nth bounce will be e raised to the nth power times v, and the maximum height after nth bounce would be e squared whole to the power n times h. And, between two bounces the maximum height must be added twice to find the distance traveled by the ball to account for the upward distance and the downward distance. Therefore, by separating the distances due to upward motion and downward motion we can identify a clever trick to add these distances up. We can notice that they are two independent geometric series and they can be summed up separately with the help of the familiar geometric series equation, which gives us the total distance traveled due to upward motion on one side and total distance traveled due to downward motion on the other. And by summing these two together we get the formula for the total distance traveled due to the ball till it comes to a complete rest.